Hello all, so I'm going to be working through some of these radical expressions with you, that way you have them as reference points as you practice. So we're going to talk a lot about radical operations, including how to multiply and divide. Some of these you may be familiar with, some of them may be new, so let's just get right into it. So for the first one, you see we have the square root of 11 squared. So squaring something actually undoes a square root, because if you remember, an exponent of 2 just means we're multiplying it by itself twice. So we have square root of 11 times the square root of 11. Well, 11 times 11 is 121. So this is the square root of 121, and the square root of 121 is just 11. Okay, so actually what we have when we are squaring a square root is that they're going to cancel each other out, leaving me just with what's underneath that radical of 11. Okay? So when you're multiplying radical expressions like in number 2, we have square root of 6 times square root of 8. Both of those are underneath a radical, so we can multiply those together. All right, 6 times 8 is 48, so square root of 6 times the square root of 8 is the square root of 48. All right, now we still have to break down our radicals. We want to simplify our radicals, pull out the biggest perfect square. All right, so it doesn't matter how you break down square root of 48 because you can use the buddy system. So we get a different color here. We got, let's say, square root of 12 and square root of 4. Well, square root of 4 is a nice number. That's 2, so that gets to come on the outside. Square root of 12 breaks down to square root of 4 and square root of 3. There's another square root of 4. So another 2 gets to come to the outside. All right, and square root of 3 is stuck underneath. So we have 4 on the outside, 3 underneath the radical. Okay, so then in a problem like number 3, you've got numbers outside the radical and numbers inside the radical. So we can multiply the numbers that are outside the radical. 2 times 7, 14. And then we can multiply the numbers underneath the radical. Square root of 6 times square root of 3 is the square root of 18. Okay, so we still have a responsibility to simplify that radical. So now I'm going to take this square root of 18 and I'm going to break that down. Okay, so square root of 18, I'm going to bring that over here. Square root of 9 and square root of 2. Square root of 9 means a 3 gets to come outside. Square root of 2 means 2 is stuck underneath. So really what we have here is 14 times 3 square roots of 2. Okay, so then we still have to multiply the 14 and the 3 together in order to get 42 square roots of 2. Okay, so we can multiply what's outside the radical together, inside the radical together, but then we still need to simplify at the end of the day. Okay, and you can always use your calculator to check. Okay, type in the original problem, 2 square roots of 6 times 7 square roots of 3. See what approximate messy decimal that gives you, and then do 42 square roots of 2, and you're going to see that those two messy decimals will match up. Okay, so for the last one with the multiplying radicals, we have 5 square roots of 7. That whole quantity is being squared. Okay, so your gut instinct might just be to say, okay, this is going to cancel that out, so we got 5 times 7, which is 35. But that's not the case. Okay, because your parentheses matter. All right, so that's not the case. We're going to erase that. What's happening is what's being squared here? Well, the 5 is being squared, and the square root of 7 is being squared. Okay, so you have the 5 being squared and the square root of 7 being squared. Well, 5 squared is 25. And the square root of 7 squared, well, now that is going to cancel out and leave me with just 7. So 25 times 7 is 175. You see how that's a lot different than just 5 times 7, which is 35. Those are not the same. Your parentheses matter. And we're going to have problems like that in this unit where you need to square something that's in parentheses, which means that exponent is getting applied to everything within that parenthesis. Okay? Another way of thinking about this is saying, okay, exponent of 2 means multiplying by itself twice. So you've got 5 square root of 7 times 5 square root of 7. So 5 times 5 is 25. Square root of 7 times square root of 7 is square root of 49. Well, square root of 49 is 7, so 25 times 7 is 175. It still gives you the same thing using that idea of what an exponent is. Okay, repeated multiplication. So that is just some examples of multiplying radicals. Let's shift over into dividing radicals. Okay, so when we're dividing radicals, we're going to go over a couple things here. We're going to go over a process that you probably haven't heard of before. It's called rationalizing the denominator. So rationalize the denominator. That means that there are no radicals in the denominator. Just in the structure of math, we do not like radicals in the denominator. So, like something for number 1, we have the square root of this fraction. Well, properties of radicals says that I can break that up and take the square root of 7 over the square root of 3. Okay? I can put both the numerator and the denominator in a radical. Now, the issue is the denominator has a radical. That's square root of 3. So, how do I rationalize it? Okay, well, what I'm going to do is I'm going to multiply both the numerator and the denominator by that radical, right? Because square root of 3 over square root of 3, that's just 1. So really, all we're doing is multiplying this expression by 1. But let's see what happens when we multiply it by 1. We're going to create an equivalent expression that does not have a radical in the denominator. All right, because square root of 3 times the square root of 3 is just 3, right? Square root of 3 times square root of 3 is square root of 9, and square root of 9 is 3. Okay, so there, the radical is gone from the denominator. And on the top, square root of 7 times the square root of 3 is the square root of 21. Now, that radical does not simplify at all. It's totally fine to have a radical in the numerator. All right, we've rationalized the denominator, which means we've created an equivalent expression that does not have a radical in the denominator. Okay? So, in number 2, we have a radical in the denominator, square root of 5. So we're going to rationalize, which means we're going to multiply square root of 5 times square root of 5. We're going to multiply both the numerator and the denominator by square root of 5. So the numerator is going to become 4 square roots of 5. And the denominator is going to become square root of 5 times square root of 5, which is square root of 25, which simplifies to 5. Nothing else to simplify there. We've rationalized, we've created that equivalent expression that does not have a radical in the denominator. Okay? So, moving on to our last two. Our last two are kind of special cases where we don't necessarily need to rationalize. All right, and let's see why. There are radicals in the denominator, right? Number 3 has a radical of 6 in the denominator, but notice we have a radical in the numerator as well. So we can rewrite this as 9 square roots of 24 over 6. Instead of both the numerator and the denominator having a radical, all right, we can put that fraction, 24 over 6, we can put that quotient, that division problem, inside a radical. And we know what 24 divided by 6 is. We know 24 divided by 6 is 4. And we know square root of 4 is 2. So we're going to get down an answer of 18. So that's one way to do it without needing to rationalize. But we can also rationalize this. Let's say we rationalized our denominator. We multiplied both the top and the bottom by square root of 6. Well, we'd get 9 square root's 144 over 6. Well, square root of 144 is 12, so this would be 9 times 12 over 6, which 9 times 12 is 108. 108 divided by 6 is 18. Okay, sorry for the wonky pen there. So it's still going to give us the same answer there, okay? But it's just through rationalizing. Okay? Last one here. So we've got 3 square roots of 3 over 5 square roots of 4. Well, maybe right away you notice that square root of 4 is a perfect square. So this would be 3 square roots of 3 over 5 times 2. And 3 square roots of 3 over 10 is as far as we can go. That's as much as we can simplify. Okay? Because if you notice, there are no more radicals in the denominator, and there's nothing after we simplify the denominator into 10. There's nothing that can simplify. 3 over 10 does not simplify at all. So that's as much as we can do. We can also, if you'd like, rationalize. It'll take a little bit longer, but that process will still be the same. We can multiply both the numerator and the denominator by square root of 4. So we get 3 square roots of 12 over 5 times 4. Well, square root of 12 breaks down into 2 square roots of 3. So we have 3 times 2 square roots of 3 over 20. Well, we get 6 square roots of 3 over 20. And then you notice 6 over 20, we can divide a 3 out of each of those and get, a 2 out of each of those. And we get 3 square roots of 3 over 10, which is the same exact problem here. All right, and again, you can use your calculator, turn it into a fraction. Look at 3 square root of 3 over 5 square root of 4. See what messy approximate decimal that gives you. And then you can type in 3 square root of 3 over 10 and see that those approximate decimals are going to match up. Okay? So not every radical, when you're dividing, not everything will need to be rationalized. There are some other patterns and properties that you can use. Okay, but this is just giving you an oversight on both dividing and multiplying radicals so that you can practice to make sure you're ready for this unit. If you have any questions, let me know. Thanks for watching.